This panel will offset 30 tons of CO2 over its lifetime. That's the number in the press release, and it's real. But before the first watt of clean power flows, something else had to flow first. Molten quartz, hydrochloric acid, and a metal so rare it trades by the gram. The supply chain for a solar panel is not abstract. It starts in 3 very specific places on Earth. Step 1 is silicon, not the beach sand kind, but quartz rock, crushed and fed into a submerged arc furnace, burning at 1500 degrees Celsius. What comes out is metallurgical-grade silicon, 98% pure, which sounds impressive until you learn the next process requires 9 nines of purity. To reach semiconductor-grade polysilicon, engineers run the Siemens process, chlorinating the silicon, distilling it to extreme purity, then cracking it back out at over 1000 degrees. The energy cost of that purification cascade is between 60 and 120 kilowatt-hours for every kilogram of polysilicon produced. That energy shock is the one most press releases skip entirely. In 2024, roughly 90% of global polysilicon production happens in China, and a dominant share of that is concentrated in a single region, Xinjiang. 3 companies, Hoshine Silicon, GCL Poly, and Tongwei, together control over 60% of global polysilicon capacity, making a single facility disruption a supply chain event felt worldwide within 6 months. Sheffield Hallam University's forensic supply chain investigation found credible evidence that Uyghur forced labor is woven into that polysilicon supply chain. Not speculation, but documented factory linkages. This is not political commentary, it is supply chain risk arithmetic, and it is now codified in US law under the Uyghur Forced Labor Act of 2022. Now let's talk about silver, the material hiding in plain sight inside every standard solar cell. Every crystalline silicon cell uses silver paste for its front-side electrical contacts, and at current deployment rates, the PV industry now consumes roughly 14 to 20% of annual global silver mine supply. One standard 400-watt panel contains approximately 20 grams of silver. At today's spot price, that's $15 to $20 of precious metal in every module. The IPCC's 1.5-degree pathway requires solar capacity to reach roughly 14,000 gigawatts by 2050, so do the arithmetic on cumulative silver demand against known recoverable reserves of approximately 560,000 tons. Silver prices and panel costs are already tracking that constraint. This is not a 2040 problem, it is a now problem, dressed in a future timeline.